Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be using QuickSurface Pro to create a version of my Kawasaki GPZ tank gauge pod. Now, we're going to start with a little bit of background on this project so you understand what we're doing and why. This is part of our GPZ build series, and this is an 83 Kawasaki GPZ 750. Back in the 80s, all the manufacturers were starting to experiment with new things. Kawasaki was one of the first to include a gauge on the tank. This was a fuel gauge, side stand, switch. It had oil pressure. It had some other stuff in it. So my plan for this bike has always been to build a GPS-based speedometer to go in this gauge pod, to also include the fuel gauge still, potentially the oil pressure light. This thing doesn't have a rev limiter on it, and when you would get over about 10,500 RPM, the oil pressure light would come on, and that was kind of an indicator of, like you're getting low on oil or you need to shift or something like that. Now, obviously there's a tack, or we're going to put a tack on the bike and everything like that, but it's just a sensor that I want to still include somewhere. So I'm going to be porting the oil pressure sensor. I don't really care about the side stand switch. That thing is gone. But I do want to include the fuel gauge. And since the bike is sort of at a different angle now, when I was riding it with the factory gauge in here, it never was right. Just because the tank was tipped so much further forward. So we need to correct that. We need to bring all these sensors in. The gauge that's in there is pretty big. It's pretty bulky, but the display that I ended up getting is a Nexion display. I think it's the 3.2-inch Discovery series. And it is narrower top to bottom, but wider. And also, unfortunately, it is a touchscreen, but it's not centered. So the rectangle, the 55 by 80 rectangle, the screen or the display is not actually centered on that. So I'm going to have to work with that to make that happen. Now, this project, unfortunately, involves a lot of different steps. So we're going to be breaking it up into many different videos and not just a single video like we have with most of the other parts. This is because I need to get all the inputs from the bike, which has not run in quite a while. So I need to do some figuring out on the resistance values for the fuel sender. I also need to get the feather and the GPS wing for the feather sorted out. I need to figure out if I'm going to try to keep the touchscreen display and what all I want to include in different gauges and things like that on the display, or if I want to seal it so that way it can actually be sort of have a little bit of protection from the elements, from the dust and the water and things like that. So all that to say is we scanned this part in one of our recent videos looking at the Einstar 2. This has a scan on the outside and one on the inside. The part does have a gasket that was epoxied in place, so it's kind of messy on the inside, and there are a couple of holes in the scan, but we have a good enough scan here that we can replicate the part. Now, I've actually already replicated what I needed and printed it and test fit it, and everything was fine. That's not the final version because there's I need to build a housing for the gauge itself, but I did at least validate that going off of this part, we can get something to work. There are a lot of different steps in this process that we need to understand. First of which is we're dealing with a plastic part that's over 40 years old. And it does have a broken corner, but other than that, it's in pretty good shape. But it is twisted. It is deformed left to right. So we're going to have to use some judgment, figure out what we want to do in terms of what we consider acceptable. Some of the features, like the little sharp parts on the back and the lip that's right here, I'm not going to build those because honestly, they're not needed. It doesn't come that close to a frame. They were just included as sort of a cosmetic feature. It's not something that I really care to replicate. So we're going to focus mainly on the basically the intersection with the tank and then the general shape, knowing that after I design the gauge, I might actually have to make this thing a little bit bigger, but we can sort all that out later. All right, so first step when we import something into QuickSurface Pro. Now I am using QuickSurface Pro because there are a couple of features in here that I think are helpful, and I will point them out as we go. You could do some of this with Light or with Personal. There will be limitations into some of the features we look at. So I'll try to point those out as we go. If you are looking to buy, we are an affiliate. You can use the code LEAD10, and I'll put all that information in the description of the video. All right, so step one is to construct a symmetry plane. Now this part again is twisted, so it's not perfectly symmetric left to right. Other than the Kawasaki logo and the fact that this corner is broken, it is actually a part that has symmetry with it. But again, because it is deformed, it's not going to be perfectly symmetric. So generally what we do is we draw a line, we dictate where we want that plane, and then we select rebuild. Now this is going to go through, it'll calculate, it'll try to analyze the mesh and figure out where the symmetry plane should actually be. And then once it has a good enough response, in this case, we can see the result, how that one corner is a little higher. We're going to look at the analysis. And what I'm looking for here is going to be essentially what we want is a very similar color bar left to right. Now, this is blue and this is red, which means this is low and that's high. Same thing over here, low and high. But you can manually adjust this if you want. So you kind of tweak it and try to get it closer and then rebuild it again. It'll use that adjustment, whether you rotated it or moved it around. Also keep in mind the analysis is 0.05 millimeters, which is really, really small. If we change this to maybe a more acceptable number, 0.5, this is more realistic for this kind of part. We're not looking at a highly precise machined part, and obviously there's some noise in the scan data. That's something we have to deal with. But changing that analysis value to something a little bit more realistic, like 0.5 millimeter, now we can see that this is actually really close. We've got low spots and high spots here, low and there, so we can kind of see the twist. That's good enough for me, so I'm going to create that plane. Now that we have this plane, I need at least one more that I can use to create, or basically to align this to coordinate system. So I'm going to extract primitives. And if you are on a pro version, then you can use this segments option. That segments option does not exist in light or personal. And then I can just select this face and create a plane. Now, before I OK that, what I want to do is make sure that plane is perpendicular to my symmetry plane, and then double check the analysis. And you can see that looks pretty good. Everything's green. We're going to create that. Now, one downside to this is we don't really have a good reference for XYZ orientation. So what I mean by that is this part sits on a gas tank and it's kind of sitting like this. The screen is pointing at the rider. None of the bosses are really pointing in the right direction. So we don't have another good reference for the coordinate system. So we're only going to use these two planes. So I'm going to go to align by coordinate system, starting with my symmetry plane. Then I'm going to go to my plane 1. Now I want to look at this and make sure X, Y, and Z are correct. I want Z to be pointing toward the rider in this case. And if we need to flip anything, we could do that. And then we'll apply. When we apply this, it'll apply it to the mesh and to all the features we created, which means the planes are going to rotate as well. And then we can close this. But once again, if I look at this from the side, that orientation may not be exactly helpful for creating some features. So we can always go to Align Interactive, and we can rotate it until it would be roughly about how it would sit on the tank. A downside to this is there is no option to move the planes with us. So when we do that, that second plane we created is now basically meaningless. So I'm going to delete it. I'm going to rotate this around. And I'm going to construct or extract another primitive. So once again, I'll click here, create a plane, make it perpendicular to my symmetry plane, show the analysis to make sure it's okay, and then we'll create that. I don't know if I need that. I mean, I will need it at some point. I don't know that I need it right now, but now we have that. All right, if you're still with me, at this point, the next step for me is to change this 1.5 million triangle or polygon mesh to something that's a little bit more manageable. If this ever has to be exported to Fusion or another CAD program, we don't want to send 1.5 million triangles because it will slow Fusion down. Now, I've worked with scans up to 10 million triangles, and while doable, it's not exactly ideal. So the lighter you can make this, the better. So under scan data, we're going to reduce the polygons. Right now, I'm going to do 50%. We're going to preview this and check the deviation of the original mesh. You can see here, 99.999%. You can even you can analyze it and see, well, there's really no area where it's not within that range. So we can go lower. We could say 25%. Now we're at roughly 370,000 triangles, 99.998. I'm going to go quite a bit lower, let's say 5%. And we'll take a look. All right, so now it's 97%. The areas where it's a little bit off are these corners. So you can see here, part of this could be this might not be an issue at all. And so if you're okay with this, then you can run with it at 75,000 triangles instead of 1.5 million, or you can start to go up. So for example, let's say preview at 6%, we're back up to 99% accuracy. So you just have to make the decision what is okay for you. Knowing this part is plastic and it's twisted, it really doesn't, that 98, 99% is probably overkill, but we've gone from effectively 1.5 million down to under 100,000 triangles. I am going to keep the original mesh just in case. So I've got the original here, and then I've got what I'm going to consider the lighter version. All right, so now that we've got a mesh that is ready to go, if you have QuickSurface, I'll leave a link in the description to where you can download the cleaned up mesh that's aligned to a coordinate system. You can also bring it into your CAD program if you want. Obviously, you can't follow along if it's going into a CAD program, but if you want to play along, I'll go ahead and I'll leave a download link to a file that can get you that mesh so you can download it and play with it. But now we need to decide how to create surfaces. Now there are probably 5 or 6 different ways that we could do this. Fit surface, or using a sweep, fill surface, freeform, auto freeform, or extracting some sketches. These are all different ways that we can create this geometry. Let's go ahead and explore a couple, and I want to first start by going to my surfacing menu and selecting 3D sketch. So the first one I want to look at, I'm going to create a path. This is snapped to the mesh. We'll create a path there, double click to end. And then I'm going to come from here. I'm going to begin coming up the mesh and double click there and say okay. So with this, what we're going to do is we're going to sweep. We're going to sweep this curve along this path, and we're going to show the analysis. This gets us pretty close. You can see that it starts to fall away as it gets to this back corner and this front corner, but overall that surface is relatively close, and then we can extend it up and down if we want to use it. That's one method where we could use, let's say, the sweep tool. Generally, I would say don't use the sweep on a face as complex as this because you'll likely get a better result using other tools. So I'm going to select and delete that sketch. I don't need it. And we're going to create another 3D sketch. The other method that we can use with these curves, and again, double click there. We're going to create a curve there. We're going to begin creating curves up here. Double click. And we'll go down to there. So the other thing that we have is we've got what's called a fill surface. We can use this boundary. We can show the analysis. And we can even use the option to do on scan data. And so on scan data will snap to the scan data on the inside of the boundary that we created. If any of these boundaries were edges of, let's say, surfaces, then we could also use tangency or curvature continuity to control them. We're going to select OK and create that. And you can see it's a little bit low in the middle, but again, for the purposes of what we're doing, knowing that I'm actually going to have to change the shape slightly, it's OK for now. And then what we would do is we would select this and extend the surface. Now you can do these individually, either natural or linear, create and stay. I'm going to go ahead and take this one down below because we're going to trim them. We'll do the front edge. If you pick the option to select edge chain, it'll grab the entire outside border, but that tends to get a little messy, especially with curves like this that are complex. But now we've got the right-hand side. Again, it's a little bit low in the middle, a little bit high in the backs, but for replicating this part, it's kind of bulged out. It's probably going to be fine. Once again, this is a plastic part that's been it's been in use for a long time. It's definitely seen a lot of sunshine, and it doesn't have the gauge screwed into it when we scanned it, which means that It's kind of a naturally deformed thing. We're going to end up mirroring that to the other side, even though we're going to end up making some modifications a little bit later. All right. The next method that we have to create some surfaces is going to be with our form tool. So I'm going to use freeform, and I'm just going to begin creating a freeform shape on this back face here. We're going to turn on analysis. I'm going to select this inside this edge here and hit S, which will split it in half. Do the same thing over here. And that looks pretty good. Then I want to take extrapolate, noting that snap mode is on currently, but when we extrapolate, it won't snap to the mesh by default. If we start to move any of these, it will. So you do need to be careful here. A little bit low in those areas, but overall that looks like a pretty good match. So we can say, okay. So now we got a surface for the back. Once again, we are going to make our own symmetry. So we're going to be trimming this stuff near the middle and then loft between them. But now we've got that top surface. On the front area here, we can use the fit surface option. Once again, on a pro license, we've got segments. We can adjust this until we get that front as a single color. Click on it and create our surface. You can always turn on analysis to see how close you are. It looks pretty good, and we'll create it. If we need to, once again, you can select these and extend them. I'm going to go ahead and just pull this upper section up, and I'll pull this lower section down, and we'll say okay. All right, so now we've got the side, which will mirror over. We've got the top. The next thing is to create this front. Now remember, the gauge opening here is going to be different. We're going to have to create a new gauge opening. So I am just going to replicate this side profile shape. So I'm going to bring back my symmetry plane, create a 2D sketch. We're going to pick our symmetry plane. And then I'm just going to create this with lines. So I'm just going to come down to where I think the corner is roughly, and then I'll come forward. And then I want to go to a corner treatment. I'm going to do a fixed fillet size. When I do a fixed fillet size there, it's going to add the dimension for me because it's automatically adding that dimension. So I can adjust it after the fact and get it as close as possible. So again, that looks pretty good. We'll say extrude, pull that out, and I'll hide the symmetry plane. And then I want to take this surface, the extended surface here, and we want to mirror it to the other side. I'm going to use my symmetry plane. We can turn on analysis if you want to see how close it is. Again, not too bad. Again, a little bit of a high or a low spot right in the middle, but overall that looks okay. So now that we have all of these surfaces, we can select them all and use trim. Now there is an automatic trimming feature if you are on the Pro license. As soon as we get too many surfaces and as soon as it gets a little bit complex, I've actually had some issues crashing my system, probably running out of RAM. So I generally manually select these. It's just a little bit safer for me because I haven't saved the design yet and I don't want to run into that issue. So let's go ahead and get all those corners and that corner as well. All right, merge face is on, so it's going to join this all into a single surface. All right, well, that's the basic shape. The next thing that we need to do is we need to trim the bottom and also trim the back, so the opening for the frame. While we don't need to necessarily have this feature here where it kind of bumps up, we could create it. Again, it's really just a cosmetic thing because it's nowhere close to the frame on the bike. And so it's really like, I don't know, 2 inches away, 50 millimeters away. So it really doesn't need to be there. So I'm not going to worry about it for what we're doing. But now I have to figure out how to cut the bottom shape. And so again, this is twisted. You can see that side's a little bit lower. So we're going to have to sort of make a decision how we want this to work. So what I want to do is go back to surfacing. I'm going to create a 3D sketch on the front of this face. And we'll finish that. If that looks pretty good, What we're going to end up doing is creating a surface, and then we're going to move that surface to the right location. So I just want to roughly match the shape. I say roughly because it's not a perfect scan. That corner is omitted a little bit, so I just want to get it close. We also have extrapolate, so we can take these endpoints and drag them out. If we're happy with it, we'll say okay. And then we want to create a 2D sketch on the symmetry plane. So we'll create a 2D sketch, pick our symmetry. And now I need to create a curve that matches this one here. This one is actually fairly close to just an arc. And so what we can do is bring it over here. And again, just try to get it close. Remember the backside, you can kind of see it here. The backside's a little bit higher because this thing is twisted. So that's about the difference between the two. And then I'm going to get on, I'm going to move this up. So I'm going to do this with offset. And where that pink dot is where the curve we created is. I'm not worried about snapping to it for right now. I'm going to turn the original one into construction. And then we're going to say okay. So now on our surfacing tools, we've got sweep. I want to sweep this along this curve. It's going to tell me that it's not in contact with the profile, but it's still going to let it happen. And it actually looks pretty good on all the sides. We'll say okay. And then we'll bring back our other surface here. All right, so we'll select both of those. Go to trim. And I'm actually going to remove the inside completely here. And we'll say okay. Once we thicken this thing into a solid, I'll probably recut that bottom edge. But for right now, I just want to work with it in roughly the right orientation. The next thing that we need to do is sort of cut out for this shape back here. Again, it doesn't need to be perfect. So I'm not extremely worried about matching that shape. It could probably even go straight across and still fit the bike just fine, but we still want to try. So what I want to do is create a plane, and under construct, we've got planes from current view, plane along path, and all these different options. So what I would say is if we take a look at, let's say, this plane right here, what I want to do is create a plane that's probably perpendicular to that one. So we're going to select that plane, go to construct, and then we're going to say plane. And actually, you know what? We could probably just cut it from the top. That would be a little bit more simple. We can define interactive. We can rotate it to an axis or anything like that. But honestly, cutting straight up and down, this is going to be fine for us. Why make extra work when we don't need to? All right, so let's create a 2D sketch. We'll create. I'm going to hide the surfaces. And now I want to basically create this cutout. Because we don't know exactly where the symmetry is in the shape, I am going to make this, here's the origin. I'm going to make essentially a line there. And then I'm going to create a tangent arc from there down to, let's say, there. That point right there, that intersection, we can click on this and make it tangent. This one that's already vertical, construction. And then this other line here will kind of come down at an angle, and then we'll come out this way. I want to do a little bit of a fillet in the corner, so we need a corner treatment. This is going to be too large. So probably 5 millimeters is going to be better. So let's reset that to 5. And I want to do the same thing to that corner as well. So we'll set this one at 5. And we need a line for the mirror. So that line is going to be construction as well. So we want to select that construction line, and then we want to select all of these curves. So I'm holding down Shift, grab all those, and we'll need to have a construction line in the selection, and then we can use the mirror selected entities option. We're going to extrude that. Make sure it goes all the way through the surface, hide our plane, and bring our surfaces back. I don't need to see the mesh right now either. All right, everything looks okay. We'll select both of those and trim. All right. The next thing that we can think about doing is either rounding the corners, or before we get that complex, we can split this thing and mirror it so that we know that we have perfect symmetry. And honestly, the only surface that is potentially, well, this front face right here and this back face are the only two that are potential problems. This side and that side were mirrors of each other, and this was just an extrude, so left to right, it's fine. But in order to make sure that this thing does actually have true symmetry, let's take our symmetry plane and let's construct basically we're going to create an offset plane. So we're select plane, and then we'll do from another plane, pick our symmetry plane, and then just pull it off to the side. I'm going to go about 11 millimeters and say okay. So now this one here and all of our surfaces, so we'll select our surfaces and that plane, and then we can trim everything off on the other side. Now we can use our symmetry plane to mirror this entire body. So once again, we'll go back to our CAD tools, mirror, and we'll pick our symmetry plane and we'll say okay. Now that we've got both sides, we can loft between them. So we'll select loft. We're going to select our curves. Again, we haven't added any fillets yet, so this should be fairly easy. And we want to make sure these are tangent so that it does follow the curvature that we cut on the front. It does follow the curvature on the back, and everything is smooth across. You can, again, turn on analysis if you've got a mesh visible and take a look. And there we go. That is our basic shape. Now that we've got the basic shape, let's go ahead and add some fillets to it. So this is really handy for us to think about the order of operations. And so, for example, this fillet right here, originally it blended into the shape. Again, we're not doing that. But this fillet right here and the fillets on the front, those were likely added before. And then this one around the gauge kind of rolls all the way around. So as I'm looking at this, what I want to do is add a fillet to this edge and this edge, turn analysis on, and then I want to go down to where it's green, or the most amount of green there. We'll create and stay. We'll do this on the front edge. Again, analysis is still on, so we'll go until it's mostly green. Again, the scan itself or the part is a little bit twisted, so I'm going to focus my attention on the original side because that's where I based everything off of. And we'll create and stay. And then this one here, we want to go ahead and start dragging that until it's mostly green. Again, I'm looking for everything that is on this side because, again, the part is twisted. So I want this to be green down here. That looks okay. Now, if you want to, you can use standard numbers. For example, if this is likely a 4 millimeter fillet, you can see that using those round numbers, it's not going to hurt anything. And then we'll say, okay. So now that is the basic part. Obviously, we need to create the opening for the gauge. You will have to decide when you're doing stuff like this, you'll have to decide if it's easier for you to do here inside of QuickSurface, or if this is something that you would want to do in a CAD program, depending on how you want to define it. For me, I always forget to save, so I'm going to go ahead and save this. I've done a lot of testing on this part, again, for the 3D printing and so on, so I'm just going to carry that naming convention. All right, if you're still with me, this took roughly about 20-25 minutes. Doing it without narration probably takes about 10 to get to this stage, maybe faster. Like if you've done this part multiple times, you could certainly do it quicker because you don't have to experiment. But I think overall, this is a pretty good result relative to the original. It matches the shape. Somebody would see this on the bike, and unless they were an expert in the Kawasaki GPZ, they would probably never know it wasn't a factory part. But now we need to make the opening for the gauge. So the way that we're going to do this is I want to essentially create the profile on that face, and I do have that plane that we created, so we're going to start by creating a sketch on that face. And because the part is symmetric about the origin, I'm going to start with a vertical line. This is just going to be a vertical reference line. I'm going to convert it to construction. Now I need to create a rectangle that is 55 tall by 80 wide. Now this is going to be the opening for the physical LED. Again, this is likely going to change because downstream, I need to account for various things that haven't been designed yet. I need to design a PCB that's going to hold the feather boards as well as a voltage regulator. The voltage coming from the bike needs to be regulated down to 3.3 volts or 5 volts at the highest. And it also needs to be sort of smoothed out in condition. So there'll likely be some capacitors in there. I also need to account for all the other inputs. So the oil pressure, the fuel gauge, anything else that I might want to include. Obviously, the GPS speedo, all is going to be on board, so there's no speed sensor or anything like that that has to happen. But because of that, what I'm going to do is I'm going to actually export the surface before I actually cut anything out, or at least a duplicate of it. But for right now, I want to make that rectangle. So I'm going to go to a rectangle, and I'm going to start by just dragging the rectangle out. I want to add a dimension. And so it's going to be 80 millimeters wide, and it's going to be 55 tall. So we can kind of see what we're working with. And then if we take a look at our line, we've got these midpoints here. So what I'm going to do is I'm going to drag a line out to here, and let's zoom in to make sure we're getting it right. A line to there and out to the midpoint. So these lines right here need to be horizontal. So this one horizontal as well. And then I also need them to be equal. So I want to select both of these, and I want to make sure that they're equal lengths. So that will center my rectangle left to right. They also need to be construction because I don't actually need them. So the rectangle is centered left to right, but it can still move up and down. And I need to decide where I want this to be and then apply a dimension. So let's say from the origin to that point, let's just come up with a number. Let's just say 14 millimeters. That's relatively close. When we begin to use these curves for, let's say, a loft, it would be really helpful if there was a consistent fillet on the corner. So let's say 5. As we do this, it's going to shift around, but if we added constraints to everything else, the equal constraint, horizontal, going from the midpoint on the left to midpoint on the right, it should work its way back into the right orientation. It is a good idea to double check that your dimensions from top to bottom didn't change, and you can see here that they did. It's now 45 when it should be 55. And then from left to right, it should be 80. And it adjusted because we started to add these fillets that ended up dropping it down 10 millimeters. Part of this depends on where you place those dimensions. If you dimension the line's actually getting shorter, so you will end up reducing your overall height based on the radii that you use. I'm going to say, okay, this is the starting point for the loft. Before I get any further, I want to export this solid, or the surface, I should say. So I'm going to go to this Q menu. I'm going to say Export Model. And I'm going to go ahead and call this a surface. It can be a parasolid file. It can be a step file. It can be an IGES file. It really depends on what you want to do. There will be some cleanup that has to happen after the fact. So if you, for example, if you may need to stitch all these surfaces back together to make one single surface. That's, again, completely fine, but now at least I have that model that I can use. The next step is for us to create an offset plane from this plane here. So again, construct plane from another plane. It's going to be plane 1, and then we need to pull it where we want it to be. I want it to stay relatively close to this face. And basically what I'm going to do is I'm going to loft out to another shape. So I'm going to say okay, and then we'll create a sketch on that plane. If we need to, we can rotate this around, go normal to sketch, Yeah, I guess it's going to look at it from the backside. That's okay. All right. So now let's hide the mesh and let's focus on our surface. So right now we're going from this shape out to essentially this shape right here. So we need to kind of match this. I'm going to do it with lines, and we're going to come, let's say, up to here. I'm trying to stay roughly parallel. This isn't a straight line, but close enough is going to work. And then I want to create an arc. Actually, you know what? Let's do one more thing first. Let's create a vertical line that is construction. And then we can select that construction line and this line, and then we can use mirror. So now if I create an arc, I can go from that point to that point and create that. On the bottom, this can be a straight line. It doesn't necessarily have to be an arc. And then we likely want to do some corner treatment. So 5 there and 5 there. Because there are no dimensions or constraints right now, it's not going to kind of go crazy, but you do still want to apply these rounded corners. And the main reason is because if we're transitioning from one shape to another, we want to make sure that we're using those sort of rounded edges. As I look at this, I think that I actually want to move this one down a bit lower. We can do that by going back to the last sketch. Sketch 4, selecting edit. And instead of 14, let's change this to 13. Actually, let's go down to 12. And so basically what we're doing is we're shifting it down. We can see the next sketch, and we just basically want this to be inside of that arc. I know it's hard to see, but we'll get there. All right, surface, loft, we're going to go from this curve to this curve. It's likely going to want to twist. If it does twist, the best thing that you can do is you can change the vertex matching. Let's hide the surface and try to get it so that there's no twist. The other thing that we can do is we can create a 3D sketch, and we can create a straight line. Oops, cancel. Let's do this. Let's do a 2D sketch. This will probably be a bit easier. And we'll go on the symmetry plane. And this will give us these pink dots where it intersects. So what we want to do is we want to basically snap between those dots, and we'll do the same thing down here. And using those dots will allow us to align as we're lofting. So back to surfacing. We're going to loft from here to here. And for guide curves, we want to pick a guide curve, and that should automatically get all the corners to look a lot better. We don't really need the bottom one. If you select it, it'll be fine. It'll probably work fine without it. And we'll say, okay. All right, so there's a little bit of twist in there. I don't really like that. I'm going to go back and edit the loft. And I want to remove, I'm going to remove the last. So I think that looks better. It's not twisting. Yeah, it's a better result. All right, and so now we have this surface, which we want to fill this opening. It's going to be flat. And then we want to take both of these and we want to trim them. Oops, I didn't select them all. Let's try this again. Sometimes when you go over here to select in the tree on the objects list, it can be hard to get all the selections, but that looks okay. All right, we'll say okay. That'll join them together, and then we can add a fillet on this corner. So this is going to be a relatively small fillet, maybe right there. I'm going to go to 1 millimeter just to make it a nice round number, and we'll say okay. So if we look at the original, obviously the original gauge was shorter in the vertical distance, so it's tapering in more. It was about the same width. You can see that it's a little bit different on the sides, but it's fairly close. But the big difference is, again, it's kind of top to bottom. We're dealing with a narrower and a wider gauge. overall, and we're going to have to use this as a bezel. So I think the final shape works pretty well. I'm going to thicken it now. And we'll need to decide which direction we want to go. Remember that this is going to be about 2 millimeters thick. So if I set this at 2 and maybe go the other direction, we can see that we're basically we're taking what we did, which matched the mesh, and we're going outward. Part of the reason for that is because I need more room on the inside. So I need to go that outward direction to make that happen. I'm going to say okay. And now I've got my solid part. Now, the last step for me really is to go back to those sketches. And let's see, we don't need the last couple. We don't need that one. We basically need these two. So what we're going to do is we're going to sweep this along that again. And then we want to cut the solid. So actually, you know what? I keep thinking about this more and more every time I do it. So we're going to take that surface. We are going to split it with, let's go here with our symmetry plane. We're going to take our symmetry plane and we're going to create a new offset plane. So we'll go from symmetry, we'll come this way, we'll say okay. And then we'll select our plane and the surface and we'll trim. So the main reason that we're doing this is because we want to mirror this to the other side and ensure that everything is mirrored left to right. So we'll go to CAD, mirror, select our symmetry plane, and then we'll loft between them. Go from there to there, make sure that they're tangent. And now we can take that and we can cut the solid with it. The other thing that you might decide to do is offset that upwards just a small amount. So maybe we'll go the other direction. We'll go up. We just want to make sure that we have a nice clean cut. So let's go up about 1.6 millimeters and say okay. And so then we can select both of those and we can use trim. You can also use the cut tool. I find the cut tool to be a little bit trickier than using trim. I use trim for most everything, but cut does work as well when you're trying to cut a solid body. But this leaves us a pretty clean edge to work with, as opposed to the thickened version, which is going to be normal to the curvature. All right, a couple more steps in this process. One is save. I never save often enough. Two is I need some references for the screw bosses. I don't need the three that are used to hold the original gauge. What I need are going to be the references for the metal brackets that hold this to the tank. So what I'm going to do is I'm going to extract primitives. I'm going to use the magic wand. Let's drag this up a little bit. And basically what I want to do is I want to create a cylinder here. So we'll create a cylinder. That cylinder, I think, should be perpendicular to plane 1. It's going to be close enough. It doesn't need to be perfect. We'll create and stay. I'm only creating them on the one side. We'll grab that. We'll create a cylinder. Once again, perpendicular to plane 1. And we'll select create. Then I want to drag these down. Depending on the geometry that you're dealing with, you can hold down control and snap to the mesh. This part is not really something that requires that sort of level. But essentially what I'm doing here is I'm creating solids that are going to be references when I send this entire thing out to my CAD program. I'm going to have those references for where those need to be, and I can mirror them across to the other side. The cylinders are shown with opacity. They're transparent by default, but you can change that. And then when we get it into CAD, we'll just mirror that to the other side. Any mounting bosses that we use for the gauge itself, those are going to have to come. I have actually started designing a housing, but honestly, it's a little bit of a waste until I design the circuit board that's going to hold all the components inside of it. The housing is going to need to account for that. And while I could just create something that was rectangular like the original, I need to ensure that the GPS antenna actually does have visibility. The feather wing that I have for this does have a UFL connector on it, so I could use an external antenna, but I already have the board. I'm already building the housing. This thing sits on the tank, so I just need to account for it. That might mean that the display itself is going to be in its own housing. There may be a second housing that puts the GPS antenna here or potentially here, because there is room between the tank and this area, so it would certainly be beneficial to have that GPS antenna either there, or let's go ahead and zoom out a little bit, or up in this area. There's loads of room. Underneath this part, the tank is actually open to the frame right there, so there is a lot of room underneath this. So I've got plenty of room to play with. I just need to make sure that it fits within all of the mounting bosses I need and that it does have the correct visibility. So we're going to have to just work on that. But at this stage, I'm going to go ahead and save this again. And I'm going to go to export model. This should include the cylinders. Let's see, with cylinders. And I'm just going to go ahead and make this a step file as well. And I also want to export the mesh just so I have it. So I'll right click, export the mesh. And we'll just call this aligned. All right, when we get it open in Fusion, we've got cylinders that are their own components. So this was exported as a step file. Each cylinder is a solid body, so we can deal with those if we want. And then we've got the solid body for the gauge. So I'm going to rename this gauge pod, and I'm going to drag this up into the top level. I'm going to call this cylinder 1. I'll call this one cylinder 2. And I'll drag this one up and this one up as well. We'll remove these components. And then now we've got the gauge pod and the cylinders. And so from here, what I'm going to do is right click and I'm going to go to direct modeling, which will take the history away. Then I'm going to bring history back. So that gets rid of all of the removing components and moving things around. At this stage, I'm not worried about adding these or joining these cylinders because really they were just going to be a reference for creating a new boss, because this thing is going to be 3D printed, at least at the start. I might actually have this thing vacuum molded. I just need them as a reference plane. And so I'm not too worried about like combining them and getting rid of the rest. If you wanted to, in Fusion, it's fairly easy. If we want to combine these two cylinders, after they're combined, I can just select and delete this stuff on the other side, and it actually will patch it pretty easily. We could have done that during direct modeling, and then I can go to mirror faces, and I got features, mirror faces. We'll take these and we'll mirror them about that plane. Oh, that one didn't seem to take for some reason. Let's try that again. All right, and so now those are in the right location for the metal tabs that are used to mount this thing to the bike. So the way this thing works is it's actually mounted to the tank when the tank is removed, and it has just two metal brackets that are right there. So I think this thing for right now is done. As I mentioned, I still need to design the gauge. I actually have a version of that right here, and I printed it and everything fits. So we're just going to have to come back to that. I'm going to need to do a little bit more work before I record anything on that. But if you have any questions on this, please let me know. As always, thanks for watching, and we'll see you in the next one.